cells correct. Okay, so what we've just covered is how much to order. So basically, these two models, the basic EOQ model and the quantity discount model, they've told us how much to order. Now, we want to know when to order. All right? And let's talk a little bit about when to order. So let me just draw here my sawtooth diagram. All right, so this is, remember, this is how it looked. All right, so it would look kind of like a shark in the water. All right. Okay, so remember we said up here at the top is the Q, and we said that the slope was the rate of demand. Okay, so down here at the bottom, this is going to be time on the x-axis. All right, so the x-axis is time, and then the y-axis is quantity. All right. All right, so let's go back to our 20 gallons of milk example. All right, so let's say we use 20 gallons a week, or let's say we do 2 gallons a day. The lead time is going to be defined as the time that elapses from placing the order and receiving the order. Okay, so lead time, LT, is interval of time to place and receive order. All right, so this interval of time right here, this would be the lead time that I've just drawn here. This is the lead time right here. Okay, LT. Okay, so what we're going to do here is we're going to define a quantity that will trigger a reorder. So let's say that, again, we use 2 gallons per day, and we initially ordered our 20 gallons. So here we go. We kind of come up here. So here's our 20 gallons up here. Sorry, here, 20 gallons. We order in 20 gallons, and we use 2 gallons per day. Let's say that our lead time, it takes us 1 day to go to the store and buy 20 gallons of milk. All right, so if the lead time is 1 day, then how much gallons of milk do we have need to be on hand that's going to trigger a reorder? And that's what the reorder point is. Okay, so the reorder point is, again, going to be equal to it's a quantity, even though it's a time. Okay, it kind of triggers us to make sure that we don't run out. So the reorder point is going to be equal to the demand times the lead time. And so in this particular case, the reorder point will equal 2 gallons per day times, and I said 1 day is the lead time, so it's going to be 2 gallons. Okay, so if I buy my 20 gallons of milk, and so after the first day it's going to be 18, after the next day it's going to be 16. So I'm monitoring what I have on hand, and when I get down to 2 gallons of milk, that is my reorder point. So that means, oh, I got to go and buy 20 more gallons, because if I don't, I'm going to run out. So that's what the reorder point is. So what affects it? Rate of demand. So you can see the higher the demand rate is, the greater your reorder point will be. The same with the length of the lead time. The greater the length of your lead time, the bigger your reorder point's going to be. If you have demand and or lead time variation, you're going to have a higher reorder point to compensate for that. And then we'll also talk a little bit about stock out risk. So if you want to have a really high service level or a very low stock out risk, then you're going to have a bigger reorder point, because, again, you're going to have to carry safety stock. All right. All right, so let me do one more thing here. It says the reorder point is expected demand during lead time plus safety stock. So again, if I were to draw my sawtooth diagram here, now here's my rated, let's say my rated demand is unknown, okay? So it looks something like this, all right? So what we have here, and so let's say that this is our lead time right here, okay? Okay. So the expected demand during lead time is just this interval of time right here. It's just, that's the only time we're exposed to a risk of stock out is when we're waiting for that next reorder to come in. And so the reorder point is going to be what's happening during just that specific period, plus then this part right here is safety stock. It's what you have in case your demand exceeds supply, okay? So this is what we're going to use. Now, when in the EOQ model where I had demand was known and constant, so with EOQ, then ROP is going to be D times LT plus 0. In that case, safety stock is 0 because you wouldn't need safety stock. Your demand is known and constant. Your lead time is known and constant. There's no way you're going to run out. You know everything. So in that case, safety stock is 0. But that situation is very rare. Usually there are lead time and demand variations that we have to compensate for. So we're going to look at some other models that allow for the more realistic demand and lead time variation. Okay, so before we get into that, think of, again, this demand during lead time as being a normal distribution curve. All right, and so the demand during lead time, the mean of this, what's happening during the lead time is kind of this is the mean right here. Okay, this is demand during lead time, the mean, the average. What happens on an average period? All right, now, if we look at the area under the curve, if we just carry what we expect on the average, then we're only going to be able to offer a 50% service level. And the service level is going to be the area of this curve. All right? So if we want a 50% service level, we carry no safety stock. It's just that simple. We're only going to be able to meet average demand. Now, usually that's unsatisfactory to many companies. They want to offer, for instance, like a 95% service level, which means 95% of the time they're going to be able to serve an order, an unexpected order, okay? So so what they'll do is they'll have a reorder point that is higher, okay, than the expected level. And so then the area under this curve now is much higher than 50%. But we've added on some additional inventory here that has come out to the right of this distribution curve. Now, this reorder point is a certain number of standard deviations away from the mean, and we're going to use that to represent that reorder point with a z-value, okay, from statistics. Now, this part of the curve here, so remember I was saying if you have like a 95% service level, well, that means 5% of the time you're going to stock out. Well, the area to the right of the reorder point is the risk of stock out, all right? So again, if in this case it would have been 5% would be the area of the risk of stock out there. And then the 95% would be my service level. And I could find that how far that reorder point is going to be to the right is going to be a function, again, of that z value, which is a function of the area under the curve that we want to cover. All right? Okay, so when you're solving reorder point problems that have demand and or lead time variation, The first thing you want to do is you want to determine if demand, if lead time, or if both of them are variable. All right. Then you can determine a service level. Or they'll either give you a service level or they'll give you a stock out risk. Once you have either one of those, you can find the Z value. And then you can find the appropriate formula to use and then solve for reorder point. And if they ask you about safety stock, well, safety stock is just the amount after the plus sign in a reorder point equation, okay? All right, so let's go and do an example. This is problem number 32. All right, it says, given that your average demand is 1,000 per day, and your standard deviation of demand, that's sigma D, is 100 per day, and if lead time is 2 days, and if your service level is 98%. Okay, so if you have a service level of 98%, what you're going to do is you're going to go to the Z table, and you're going to find the Z value that gives you a 0.98 area. Or you can just use Excel, and you can find that that value is, the Z value is 2.05. All right, so if we are 2.05 standard deviations above the mean, we will cover 98% of the area under that curve. All right, now if you notice, another thing you notice is you're given an average demand and a standard deviation demand. This is a variable demand, constant lead time problem. So whenever you're given standard deviation, either of lead time or demand, you know that that's variable because standard deviations come with distributions, and distributions mean that you're not dealing with one number but a distribution of numbers. So the variable demand constant lead time formula is basically, I'll just type it right here, right above here. So this is our reorder point equals D times lead time plus Z times sigma D times square root of lead time. Okay, so that is the formula for a variable demand constant lead time problem. So you just put that in, and you can find out that your reorder point is 2,290. The safety stock is anything after the plus, which would be 290. Okay, so again, this is, you have to find out what you're given, find out your Z value from the area, and then figure out what type of formula that what they're giving you falls with, okay? That's the easiest way to do these problems. Okay, another example. They give you that the average demand during lead time is 50. They give you that the standard deviation of demand during lead time is 5. And they give you a service level of 97%. So again, we can use the equal norms inverse, or we can just go to the Z table. We can find out that the Z value that covers 97% of the area is 1.88. Then in this particular formula, when we have the distribution of demand during lead time, the safety stock is going to be Z times sigma DLG, which is going to be 9.4. So then the reorder point is the demand during lead time, which is 50, plus the safety stock gives us a reorder point of 59.4. So the last example, well, I didn't do an example, but again, if you look in the book, they give you reorder point formulas for variable demand, constant lead time, constant demand, variable lead time, variable demand, and variable lead time. And then also when you're given the distribution of demand during lead time. That's equation 12-13. So the reorder point part does have a lot of formulas, but again, you just need to really read the problem, see what you're given to be able to select the appropriate formula to solve for either the safety stock or the reorder point. Okay, so just as a friendly reminder, so there's a couple things due this week. Today is Monday, so your first exam is going to be due Wednesday. I believe I set the due date on that. And then also your Chapter 12 homework will be due this Sunday at midnight Central Time, okay? If you do have any questions, feel free to let me know via the discussion board or email me directly. And hopefully you have a good week. So I will talk to you all next week. And again, if you need anything, just send me a quick email. All right? Take care. Bye-bye.